Hello, today we are going to look at the areas of trapezoids, rhombi, and kites. We have two different formulas for today. The first one is the formula for the area of a trapezoid. A trapezoid has an area equal to 1/2 times its height times the length of its two bases. Remember, in a trapezoid, the bases are the two parallel sides. Here they're on the top and the bottom, but they don't necessarily have to be. And then remember also that the height of every single shape is always going to be perpendicular to its bases, or base, depending on how many there are. If you take a look at the first two examples, it says find the area of each figure. So in question number 1, we have a trapezoid. Here the bases happen to be the top and the bottom again, because they're shown to be the two parallel sides. So in order to find the area of this trapezoid, we're going to use our formula 1/2 times the height times the sum of the bases. Remember, B1 and B2 just represent the first base and the second base. So here I have 1/2 times, if the height of the trapezoid is perpendicular to the bases, then here the height of our trapezoid is 12 times the sum of the bases, so 16 and 24. When we multiply all of this out, the area of the trapezoid is 240 yards squared. In the second picture, the trapezoid we're finding the area of is the shaded portion of the picture. They have the dotted lines in order to show us the height. So in this picture, our two bases happen to be the left and the right sides, the two parallel sides. And then our height, perpendicular to that, is this 28. So again, area of a trapezoid, 1/2 times the height times base 1 plus base 2. So here our height is 28. And the bases are 12 and 24. When you put all of this into your calculator, you should get that the area is 504. And here they didn't give us any units, so we're just going to write the word units squared. The other two shapes for today, rhombi and kites, share a formula for area. The formula for the area of a rhombus or a kite is 1/2 times D1 times D2. And that means diagonal 1 times diagonal 2. Remember that a rhombus has 4 sides that are the same, diagonals that are perpendicular. The diagonals bisect each other, but they are not congruent. In a kite, 2 consecutive sides are congruent. Again, the diagonals are still perpendicular, but both diagonals do not get bisected. Only the one that connects the non-congruent sides gets bisected. If you take a look at question number 3, here we have a rhombus. We can see all 4 sides are marked the same. So to find its area, we're going to do 1/2 of diagonal 1 times diagonal 2. In this picture, one diagonal is labeled as 20 meters. The other is 24. So when we multiply 1/2 of 20 times 24, we should get 240. And this is in square meters. Question number 4 is a kite. They've labeled the 2 diagonals for us again. So we're simply plugging into our formula. 1/2 of diagonal 1 times diagonal 2. So here we have 1/2 of 16 times 9, or 72 square inches. Okay, things get a little bit more exciting when we get to something like question number 5. In question number 5, we have a kite. So in our kite, we know the diagonals are perpendicular. We know that we need the length of both diagonals in order to find the area, but we don't have the length of either diagonal. So I'm going to start this question by focusing in on this triangle. I know that this 58-degree angle and the angle right next to it have to be the same. So I'm going to label this angle as 58 degrees as well. Then I'm going to label the two legs of this right triangle, X and Y. If I have a right triangle, I only have one side, but I know the measure of one of the acute angles. I have to use my trig functions to solve for the length of the legs. So think all the way back to ka, toa. I'm going to first solve for side X. So if I'm sitting at 58 degrees, X is the adjacent side, 4 is the hypotenuse. So I can create an equation using cosine. So the cosine of 58 degrees equals adjacent X over the hypotenuse 4. To get X by itself, multiply both sides by 4. So X is 4 times the cosine of 58 degrees. When you type this into your calculator, please make sure that you're in degree mode and not radian mode. You should come up with a value of 2.1. Okay, then let's solve for Y. To find the side that I labeled Y, I'm still imagining sitting at the 58-degree angle. Y is now the opposite side. 4 is still the hypotenuse, so opposite and hypotenuse go with sine. So the sine of 58 degrees equals opposite, which is Y, over the hypotenuse, 4. Again, we're going to multiply both sides of the equation by 4. And when you type into your calculator, 4 times the sine of 58 degrees, Y should be 3.4. The two values that we just found are half of each of the diagonals. So if X is 2.1, the vertical diagonal, this entire thing, is double that. So let's call it diagonal 1, and that will be 4.2. If Y is 3.4, half of the horizontal diagonal, then that entire diagonal, call it D2, is about 6.8. Now that we have the two diagonals, we can find the area. So we multiply for a kite or a rhombus, 1/2 times diagonal 1 times diagonal 2. So 1/2 times 4.2 times 6.8 makes our area about 14.3 yards squared. Okay, when you flip over to the back, question number 6. Trapezoid NOPQ has an area of 250 square inches. Find the height of the trapezoid. So we have our starting area. We have the two bases. Here we have to solve for the height. We're going to use the same formula for area. So for a trapezoid, that's 1/2 times the height times the sum of the bases. Plug in all the information that we have. So here I have the area is 250. So that equals 1/2 times. I'm going to leave h for the height since that's what we're solving for. And then the two bases are 20 and 30. When I clean up the right side of this equation, if I add 20 plus 30 is 50, and then multiply that by 1/2, 50 times 1/2 is 25, and we still have the h. And then when you divide both sides by 25, h should be 10. So for your final answer, the height of this trapezoid is 10 inches. Question number 7, we're given a rhombus. Again, we have the area of this rhombus. We have one of the diagonals. We need to find the length of the other. So like the last question, let's write down our formula. For a rhombus, that's 1/2 times diagonal 1 times diagonal 2. So 675 equals 1/2 times, our t is the diagonal that we have, so 15 and 15 or 30 meters long. SU is the other diagonal that we're solving for. So 675 equals 15 times SU. And when you divide both sides by 15, SU will be 45. And this should be meters. Okay, question number 8. One diagonal of a kite is twice as long as the other. If the area of the kite is 240 square inches, what are the lengths of the two diagonals? So let's call the first diagonal plain old x. The second diagonal is twice as long as the first. So we can call that one 2x. A kite has the same area formula as the rhombus. So area equals 1/2 diagonal 1 times diagonal 2. We know the area of the kite is 240. So that's going to equal 1/2 times x times 2x. Half of 2 is just 1. X times x is x squared. So we have 240 equals x squared. And when we square root both sides, x is about 15.5. We were asked to find the lengths of the two diagonals. So the first diagonal was just x. So the first diagonal will just be 15.5 inches. The second diagonal was 2x. So 2 times 15.5 is about 31 inches. And for the final question, it says a trapezoid has a height of 8 meters, a base length 12 meters, and an area of 64 meters. What is the length of the other base? So let's draw ourselves a trapezoid. It does not need to be accurate. I'm going to make mine look like this. Okay, the height we know is 8 meters. One base is 12 meters, and we're looking for the length of the other base. Area of a trapezoid is 1/2 times the height times base 1 plus base 2. When we plug in what we know, 64 equals 1/2 times 8 times one base we're looking for, so we'll just call that B, plus the other base we know, which is 12. 1/2 of 8 is 4. And then we can distribute the 4 into the parentheses. So 64 equals 4b plus 48. When we subtract 48 from both sides, 16 equals 4b, which makes b 4. So for our final answer, the other base of the trapezoid is 4 meters long. Have a great day. If you have any questions, please make sure you let me know and complete